When computing the probability of at least one, this means at least one outcome of a fixed number of outcomes will occur. Recall that at least one is equivalent to one or more. And there's a probability formula we want to employ whenever we encounter this type of question. So whenever we see the probability that at least one item has a specific property, this is the same as 1 minus the probability that none have that specific property. So keep this formula in mind when working out problems. Let's take a look at an example. It says the following: it's estimated that 76% of people suffer from hormonal imbalance. If 3 people are selected at random, compute the following. Part A says all 3 suffer from a hormonal imbalance. None of the 3 suffer from a hormonal imbalance. At least one of the 3 suffer from a hormonal imbalance. Now for part A, we use multiplication rule number 1. All 3 suffer from a hormonal imbalance. The chance that 1 suffers from it is 0.76. Since it's 3 suffer from it, you can just simply raise it to the 3rd power. And that's going to give us 0.439. Now for part B, we first have to compute the chance of not having a hormonal imbalance. So the chance that someone does not have the imbalance is 1 minus 0.76, 0.24. And then we will use multiplication rule number 1 to compute the probability that all 3 do not have the hormonal imbalance. This is done by just taking 0.24, raising it to the 3rd power to get 0.014. Now for part C, that's where we actually apply our formula we mentioned above. At least one of the 3 suffer from a hormonal imbalance. That's going to be 1 minus none of them do, while the probability that none of them suffer from the imbalance is 0.014, and 1 minus 0.014 is 0.986. In the second example, it says a coin is tossed 5 times. Find the probability of getting at least 1 tail. Well, whenever we see the probability for at least 1 tail, using our formula, it's 1 minus the probability that none of the 3 is a tail. So that's 1 minus the chance it's not a tail means it's heads. So it's going to be 1/2 to the 3rd power. And then actually we want it to be to the 5th power, right? Because we're tossing a coin 5 times. And then 1/2 to the 5th power. That's 1 out of 32. And then we can complete the result. 1 minus 1 out of 32. Using the calculator, we have 1 minus 1 out of 32. That's going to be 31 out of 32 is the answer. And for the third example, it says if 3 cards are chosen from a deck without replacement, what is the chance that at least 1 is a heart? For this problem, we have to keep in mind that these events are dependent. In these previous 2 examples, the events were independent. That's why the probability was the same for each trial, and why we used the power to calculate the probabilities. But when we're selecting cards without replacement, that means every time you select the card, the probability will be modified. So it says, what's the chance that at least one is a heart? Well, we use our formula. It's 1 minus the probability that none of the three is a heart. Well, how many cards are not hearts? We can look at our deck of cards. We have 52 cards. There's 13 hearts. 52 minus 13 leaves us with 39 cards, diamonds, clubs, and spades that are not hearts. So the chance that the first of the three cards is not a heart is 39 out of 52. Remember, we're selecting without replacement. Once you pick the non-heart, you cannot pick it again. So now the probability is modified to 38 out of 51. Once one of these cards is selected, and we're assuming it's a heart, not a heart, we get 37 out of 50 for the third probability. We multiply these out to get, and we convert it to a decimal, 0.413. And finally, 1 minus 0.413 is 0.587. So just be careful. Sometimes we have dependent events where the probability is slightly modified. Other times the events are independent where the probability is the same for each selection. So keep that in mind when working on these problems. Thanks for watching the video.